Hi everyone, welcome back. So this time we're going to do an example where we use the method of sections to solve for the forces in members Kj, right here, Kd, and Cd. So luckily for us, it looks like there'll be a nice little cut right there we can do to achieve this. So what's your plan? Well, take a cut through the members. You can work with the left or the right side. I would say work with, either one will work. Then determine the support reactions and apply your equations of equilibrium to solve. As a note, you don't have to cut it before you can solve for those support reactions. You can do that from the very beginning if you wish. You don't have to, but you can. I honestly find, probably be easier after you cut it. No, it'll be easier before you cut it. Why in the world did they ask you to do it after you cut it? How it is. So, I'll give you 3 seconds to go and try this on your own. So, 3, 2, 1. Go for it. Okay, well, you've already gone for it. Now you're back, and hopefully you did it correctly. Let's find out. So as usual, I don't always agree with how they solved the problem, but okay, they weren't silly. They actually did it before they cut it. They just get the plan wrong. And I want to figure out these support reactions because I'm only going to work with the left side. Well, first off, we realize that there's no forces in the x direction, so AX is going to be equal to 0. Second, I really want to find out what AY is. And so I'm going to take the sum of the moments around point G because then this force does not cause a moment. And I'm only left with one unknown. So AY times 12, minus 20 times 10, minus 30 times 8, minus 40 times 6, all of these guys right here. We get that AY is 56.7 kilonewtons. So I know all the unknowns on this side before my cut. And now I cut. I'm left with something that looks like this. I get the slope triangle just by looking at the geometry. It goes over 2 and down 3, so 2/3. I know what these are, 56.7 kilonewtons going up, 20 kilonewtons, and 30 kilonewtons right here. And now I've got to solve for all of these. Once again, it's very, very simple if you're careful. Like if I take the sum of the moments around this point right here, I can solve for force CD just by itself. Then if I do some of the forces in the y direction, I can solve for force KD by itself. And if I do some of the forces in the x direction, I can solve for force Kj by itself. 3 equations, 1 unknown per equation. So just really think about it. It can make things a lot easier on you. So I did it exactly like I said. Just moments around, it says point D actually. It's being weird. But okay, it decided to do around point D, which is over here. Which also works just fine. And so we're able to solve for force Kj, which is 66.7 kilonewtons. Because neither one of these will have a moment. I would have done around point K, but similar process. Now that you know that, you can do some of the forces in the y direction. There's only one force that has a y component, which is force Kd. And so we have all of these other ones, 56.7 kilonewtons, 20 and 30 kilonewtons. And then we have to get the component of force Kd in the y direction. Well, we can look at the angles if we want to, or we can just use opposite over hypotenuse, because that would be the y component. So that's 3 over the square root of 2 squared, which is 4, plus 3 squared, which is 9, which gives us 3 over the square root of 13. Which is what we get right there. From that, we solve for force Kd. We have only one last equation, which is sum of the forces in the x direction. And if we use that, we get that force CD 62.2 kilonewtons. So it works out good, works out fun, and we're able to solve. And you can see that everything worked out fine with how they drew the arrows. However, if you draw the arrows wrong, you'll just get a negative sign, which tells you need to flip it around. Or if you drew it as tension, it was supposed to be compression. If you drew it as compression, it was supposed to be tension. So remember that. So you can see here, hopefully you remember this, that the equations you choose, especially this one moments, the point you choose is super important, and the equation order you choose will really either drastically increase or decrease the difficulty of a problem. I've seen some people who are trying to do this terrible 6 sets of equations trying to connect them all, but in the end they could have solved just for one unknown per equation if they had just looked at it slightly differently. If it seems too hard, you're probably just not looking at it right. So take some time, see if you can find the easier way to do it. Make it simple. You can do this. So I hope this helps you. I'll see you all next time as we do some more fun examples. Bye-bye.